Welcome, everyone. In this video, we'll explore essential built-in hooks, such as useState and useEffect, and demonstrate advanced custom hooks, including useDebounce and useTrottle. You'll gain the knowledge to write more efficient, maintainable code in under 10 minutes. Let's begin. useState is the core hook in React that lets you add state to functional components. Before hooks, we needed class components to manage data that changes, like a counter or form input. With useState, we can do it all in functions. Think of it as a box for your data and a key to update it. useState returns an array with two elements, the current state and a function to update it. We name them, say, state and setState using destructuring. In programming, this is called a tuple, a pair of values. The first is what we read, the second is what we control. That's how React knows when to re-render the component. To understand why we need useState, let's look at a counter. In plain JavaScript, we update a variable and refresh the DOM. But in React, every render is a fresh function call. If we use letCount equals 0, it resets to 0 on every render. Click the button, nothing changes because React doesn't track it. Here's how useState works in a counter. We import useState from React and call it with an initial value of 0. That's our starting state. We get count, the current value, and setCount, the updater function. Clicking the button calls setCount, count plus 1, incrementing count. React detects the change and re-renders with the new number. But what if the initial value requires heavy computation? We pass a function to useState. In this example, we sum numbers from 0 to 1,000,000, a slow task. Without a function, this would rerun on every render, slowing things down. With a function, it runs only once on mount. Check the console. After that, we can update the state normally. And one last thing about useState. If you want to make sure that you use the most recent value of your state, use the callback function with previous state value in params. This matters when React batches updates. It ensures we work with the most current state, avoiding errors. useEffect is the hook for side effects, fetching data, updating the DOM, or subscribing to events. It runs after the component renders, syncing it with external systems like APIs or the browser. useEffect takes two parameters, a function where we define the effect and a dependency array. The function runs after rendering, and the array tells React when to rerun it. No array means every render. With an array, only when dependencies change. The dependency array is a list of values useEffect watches. An empty array means the effect runs once on mount. With variables, it runs when they change. No array, it runs on every render. Let's take a look at examples. useEffect without dependency array updates every render. With an empty array, useEffect runs once on mount, like component did mount. In this example, it logs a message to the console just once when the component appears. Here, useEffect depends on count. Each button click updates count, and the effect logs the new value to the console. The dependency tells React, run this effect whenever count changes. useContext lets you access data from a context directly in a component. Context is a way to pass information, like a theme or user data, through the component tree without props at every level. useContext is often used for themes, authentication, or global settings. In this example, we create a theme context with a default light theme. In the app, we switch the theme via a provider, and the component grabs it with useContext to style itself. Click the button. The theme flips. useRef is a hook that returns an object with a .current property. This object persists across renders, but changing it doesn't trigger a re-render, unlike state. This hook is often used to interact with DOM elements. Here we create an input ref and attach it to an input via the ref attribute. Clicking the button calls focus on .current, putting the cursor in the input. useMemo memoizes a computation's result and recalculates it only when dependencies change. It's an optimization hook for expensive operations you don't want to repeat unnecessarily. useMemo is great for optimizing computations. Without it, a calculation runs on every render. See the console. With useMemo, it runs only when the input changes. Click Add. The result updates, but no extra work happens. useCallback is a hook that memoizes a function, ensuring it doesn't get recreated on every render. Without it, a new function is made each time, which can trigger unnecessary re-renders in child components. useCallback locks it in place, boosting performance when it matters. Now, how's it different from useMemo? Both memoize things, but useMemo returns a value, like a computed result, while useCallback returns a function. Think of useMemo for numbers or data, and useCallback for reusable actions. useCallback shines when passing functions to memoize child components. Here's a counter. Without useCallback, the button's on-click recreates every render, forcing the child to re-render. See the console logs. With useCallback, it's stable unless dependencies change, so the button stays put. Click away. The count updates, but the child only logs once. useReducer is a hook for managing complex state logic. When useState feels too simple, like juggling multiple values or tricky updates, useReducer steps in. It's like a mini Redux. You define a reducer function to handle actions, making state predictable and organized. useReducer is perfect for state with multiple actions. In this counter, we have increment, decrement, and reset. We define an initial state, count at 0, and a reducer to handle actions. Click a button, dispatch sends an action type, and the reducer updates the state. It's clean, structured, and scales well for bigger apps. Custom hooks are our own functions that use React hooks to make logic reusable. Let's check out some popular examples. useDebounce delays updating a value for a set time. It's perfect for search or actions where you don't want to react instantly. The hook takes a value and a delay, waits for changes to stop, then updates the result. In this example, we type in an input. The raw value updates instantly, but the debounce value waits 500 milliseconds after the last change. Then useEffect logs it. Great for cutting down API calls. useTrottle limits how often a value updates, like for scrolling or resizing. It takes a value and a time limit, ensuring updates happen no more frequently than that interval, keeping your app lightweight. Here we track scroll position. The raw scroll updates constantly, but the throttled version updates only every 200 milliseconds. The console shows values arriving at a steady pace, saving resources during fast scrolling. useLocalStorage saves state in the browser's local storage, so it sticks around after a reload. It's like useState, but with memory between page refreshes. In this example, we build a counter that saves to local storage. Click increment, refresh the page, the number stays. It's perfect for settings or progress that needs to last. useFetch is a hook for grabbing data from APIs. It returns 3 things: the data, a loading state, and any errors. Everything you need for API calls, bundled up neatly. Here we fetch a post from JSON placeholder. First you see loading, then if something goes wrong, an error, and finally the post title and text. useFetch makes it straightforward and reliable. That's it for React hooks. We covered built-in ones from useState to useMemo, and custom ones from useDebounce to useFetch. They make your code cleaner, faster, and easier to manage. If you enjoyed this, hit like, subscribe, and drop a comment with your favorite hook. See you in the next video.